Hello, let's get into factoring. Most students have a problem with figuring out the correct signs and adding and subtracting integers. So let's do a little practice. Sum and difference of polynomials. Let's rewrite this problem and stack the like terms on top of each other. Notice there's spacing that happened because two terms did not have any matches in the other set. So let's start at the back. Let's focus on the 5 and the 3. When the signs are the same, add the numbers and keep the sign. So this is positive 5 plus positive 3, which will give you a positive 8. Let's move to the next term to the left. If you notice, there's no like term here, so let's just bring it down. Same for the next term. Okay, so the last terms on the far left, similar to before, both terms have a plus sign. We just keep the sign and add the numbers. So we should get 14u to the third power. Done. Let's rewrite this problem and stack like terms on top of each other. If you notice, in the first set of parentheses on the first row, I rearranged the problems in descending order, just so that they can match their partner, their like terms in the other set. Let's start at the back. We have positive 5 minus a negative 5. What happens right here? That's right, it changes to a plus. So now we have plus 5, and what is that result? Positive 10. Moving to the next terms to the left, we have negative 7 minus negative 9. What happens here? You guessed it, it changes to a plus. So now we have negative 7 plus 9. But what do we do when signs are different? We subtract the small from the big, keep the sign from the bigger number. So in this case, we subtract 9 and 7, which will give us a 2. But because the 9 is a positive, it's going to be a positive 2x. Please make sure you're watching over to the right and not where the problem is highlighted on the screen, simply because we have to adjust the signs. Now let's move to the last term. We have negative 5 minus negative 7. What happens here? You guessed it, it changes to plus. So now we have negative 5 plus 7. What do we do when the signs are different? Subtract the small from the big, keep the sign from the bigger number. In this case, we subtract 5 from 7, which will give us a 2. And since the 7 is the bigger of the two, bigger of the two numbers, we're actually going to have a positive 2, x to the fourth power. Let's walk through this one. So there's less words on the screen, but I'm just going to talk you through it. So let's start off with the stacking of the like terms. We have in the back negative 6 minus a negative 2. We know now that that's going to change to negative 6 plus 2. What should be the result? Negative 4. Remember, if the signs are different, subtract the numbers, keep the sign of the bigger of the two numbers. What happens in the next term? Negative 6, subtract a positive 4. Now this is interesting, different from the previous problems. We have a negative and a plus. So who wins out? It's going to win out with the minus. It changes to an official minus. So now we have -6 minus 4. And what is that result? You guessed it, -10. Because when the signs are the same, just add the numbers, keep the sign. Last one, 7 minus 4. This one should be easy. It's self-explanatory. Subtract the small from the big, keep the sign of the bigger number, which is 7 in this case, so it's a +3 at the beginning. Now I think you're ready to really dig into some factoring. So here's our first problem. So think of factoring like dividing. We're pulling out what's in common with a group of terms. You must consider the numbers and the variables separately, but at the same time. Confusing? Just watch. So I'm looking at my numbers, 14 and 8. What is the biggest number that they can both be divided by? Did you guess 2? That's correct. Now let's look at our variables. How many w's can both w to the 7th power and w to the 4th power have in common, or can they give? They can each give 1 w. That'll be okay. Can they give 2? Yes. 3? Yes. 4? Yes. What about 5? No, not 5, because the smallest of these two terms, W4, he can only give at most 4, whereas W7 can also give 4 without going over. So that's going to be W4 for both of them. Now let's divide out the 2w to the 4th power from both terms. I'm going to put a division symbol under here, and we're going to do each one. So over here to the right side, the W4s are going to cancel. So whatever's left over there is just going to be a number when we get to that part. In the front, I have 14 divided by 2, which should be a 7. And 7 W's take away 4 W's should give us 7W3. And then like I said, because W4 has canceled out on the second term to the right, it's just 8 divided by 2, which is 4. Okay, so now the factored form of our original problem is 2w to the 4th power, 7w to the 3rd power, plus 4 in parentheses. Let's try that again. Okay, now we have 3 terms. Again, look at the numbers. I'm not looking at the signs, just the numbers. 30, 48, and 6. What is the biggest number that they can be divided by all 3? Did you guess 6? 6 would be right. Variable-wise, how many b's does B5, B2, and B have in common? Did you guess just 1 b apiece? The best way to figure this out is always go by whoever has the lowest. In this case, B, our last term, that's the most he can give, and so at the minimum, that is what all of them can give. We're going to go ahead and divide it out. There's my division line. Take each section one at a time. So -30 divided by 6 is -5b to the 4th. 48 divided by 6 is 8 with just a b. And 6b and 6b are going to cancel, so that's just going to be a 1. Okay, so what's our factored form of this original problem? 6b on the outside, parentheses, -5b to the 4th power plus 8b plus 1. Not bad. There are several different types of polynomials, and the factoring technique changes. So 2 important skills needed is that you need to know your multiplication tables, the rules of divisibility, and being able to add and subtract integers pretty well with the signs. So here's our first problem. We're going to start at the back and list the factors of that number, which is 77. Now you have to ask yourself, which pair of factors, 1, 77, or 7 and 11, will give you the middle number? Did you guess 7 and 11? In this case, 7 and 11 can add together to make 18. Okay, so let's set up our template with the pair of parentheses. The leading variable, which is w squared, is separated into each parentheses, which is w times w. Now, you can put your factors, 7 and 11, order does not matter, into the parentheses in the back. Now the hard part. Remember, anytime we add, the signs will be the same. Either they will both be plus or they're both minus. Which is it for this problem? Did you guess plus? Remember the sign of the middle term, which is positive 18w in this case, controls the sign of the parentheses. Let's try this problem. Start at the back and list the factors of the number. Choose a pair of factors that will add or subtract to give you the middle term number. Do not be concerned about the signs at this moment, just trying to get the numbers to work. 2 and 7, in this case, will add to make 9. Set up your parentheses, plug in your factors. Now, remember, if we're adding if we're adding the numbers, the signs will be the same. Either they're both going to be plus or both of them will be minus. Which is it for this problem? I hope you guessed minus. Remember, the sign of the middle term, which is -9 in this case, determines the signs in the parentheses. Let's try this one. Start at the back, 42, list the factors. Choose a pair of factors that will add or subtract to give you your middle term number. In this case, our middle number is actually a 1. Did you guess 6 and 7 can subtract to make the 1? Set up your template of parentheses. Insert your selected factors. Order does not matter. Now, remember, anytime we subtract, the signs will be different. That means there's 1 plus and 1 minus. Remember, the bigger of the two numbers, which in this case is 6 and 7, 7 being the bigger number, he retains the same sign as your middle term number. So since in the middle is a minus and 7 is the bigger number of the two, he gets the minus and the 6 gets the plus. Again, the sign of the middle term controls the signs in the middle, in the parentheses. Let's try this one. So recognize that the perfect square at the back and there's no middle term. This is called a difference of squares. So we don't need to list the factors. You should already remember that 49 and 7 are related. It takes 7 times 7 to make a 49. So set up your parentheses. Insert your 7s to represent 7 times 7 is 49. And automatically write in 1 plus, 1 minus. Doesn't matter the order, plus could have came first, minus second, the numbers are the same. The reason is because a -7 plus a positive 7 equals 0, which removes there being a middle term. Remember, the sign in the middle term controls the signs in the parentheses. Since there's no middle term here, the signs actually cancel each other out because it's the same number. All right, starting to get bigger here. So from the rip, notice we have a number in front of our leading variable. In all our previous problems, there was no number other than the number 1 in front of our variable with the squared on it. So that already makes this difficult. And then when I look at my middle number, it's an 80. It's a really big number, bigger than what we've had before. So we need to factor our numbers in order to reduce this problem a bit, and then we can start. So what number can 12, 80, and 28 all be divided by? Did you guess 4? That's right. So divide by 4 under each of the terms and put it in parentheses. None of the signs change, just the numbers get to be reduced. That looks better. So next, we multiply the front and back numbers together. This will be our number that we list the factors for. So 3 times 7 is 21. Let's list the factors out. All right. Did you guess 1 and 21 subtract to make 20? Very good. Now I'm going to rewrite the problem with these factors, the 1 and the 21, and I'm going to replace our middle term with them. So notice I wrote it out, plus I have my signs. 21r minus r equals 20r, which is right above it. Next, we're going to factor the terms 2 at a time. For the first time, we instead of just 2 or 3 things, we actually have 4 terms to deal with. So it's better to take it in small groups. So we're going to take it 2 at a time. We're going to start right here. The 4 that sits out in front will not be touched just yet. It's just sitting out there. We already took it out of the equation for right now. All right. So when I look at 3r squared plus 21r, again, consider your numbers. What's the biggest number that they both can be divided by? Look at your variables. What is the most that each term can give for their variables? Hopefully you guessed that it's 3r for both of them. Once you determine what your factor number is that you're taking out, you divide each of your terms by that. And what we're left with is r plus 7 on the inside for that group. Let's try the next one. On this part of the problem, there's only one letter, one variable, and one number. Numbers and variables don't have anything really in common. But what I do see that they both have is a negative sign. And you can take that from both of them. So that's really going to be a -1 sitting outside the parentheses for this group. And what happens is anything divided by a negative flips to a positive. Okay, we're almost done. Notice that we have an r plus 7 repeating in our problem now. Now we can use that to write our final factored form. So I'm going to take the r plus 7 and move it to the front and write it in parentheses. Then for my second set of parentheses, I'm going to write what was left over from the previous line, which is the 3r and the -1 will go together inside the parentheses. Done. Let's see that again. Here's another problem. We had a big middle number, but always from the rip, if you have a number bigger than 1 in the first term where the p squared is, if it's bigger than 1, try to look and see if you can reduce the problem by dividing everything by some number that they all have in common. In this case, 3 is the best number to divide all numbers by. Divide out the 3 and write what's left. Okay. Just like last time, we're going to multiply the front and the back numbers together, and that's going to be what we list the factors of, which is 54. So I'm going to list my factors. All right. And now I have to look through the factors and I need to pick a pair of numbers that will give me 29. 2 and 27 works. In this case, 2 and 27 add together to make a 29. All right, now I'm going to rewrite the problem with these factors replacing my middle term. So instead of writing 29p in the middle, I have 27p plus 2p, which represents those factors off to the side that were circled from before. Now we're going to factor the terms 2 at a time. So 3p squared plus 27p. What's the biggest number I can divide the numbers by, and how many p's can I take out at one time? Hopefully you guessed 3p. Divide and leave in parentheses what's left, which should be p plus 9. Let's do that again over here. 2p plus 18. Well, in this case, both terms, only one of the terms has a variable, which is 2p. 18 is just a number. So at the very least, all we can do is reduce this dividing by 2. Okay. Just like last time, notice that we have our parentheses as repeating. And so we're going to use that to help us write our factored form. So p plus 9 can go to the front or to the back, depends. And whatever was left over outside those parentheses, which is 3p in the positive 2, goes in their own set of parentheses. Here are some problems that you could try. Hopefully you will find your way to get to the exact answers that are on the screen. Hope you learned something, and thank you for watching.